By now we have a general understanding of who Audinate is, what Audinate does, and the basics of digital audio. Next, let's dive a little deeper into Dante AVIO. In order to do that, we'll go into more detail about Dante AVIO hardware and software solutions. Let's start with a bit of history on Audinate's chipsets. Over the years, these chipsets have evolved to meet new market demands, but they remain fully compatible with existing Dante devices. Dante is 100% interoperable, whether your endpoints use hardware or software, and regardless of the manufacturer or firmware version. As part of this evolution, Audinate has transitioned from proprietary Dante chips to software-based solutions, enabling Dante to run on ARM-based microprocessors and FPGAs. This shift has made Dante more flexible and cost-effective, allowing manufacturers to integrate it into existing hardware without dedicated chips, further expanding its adoption across the Pro AV industry. This table provides a comparison of the legacy and new chipsets and software solutions. All of the hardware and software that we've discussed so far is focused toward companies who are developing products with Dante. Let's switch gears and talk about some of Audinate's end-user-focused products. We'll start with the AVIO line of adapters. Whether your role is at a recording studio, on a live stage, or managing an installation, seamless AV connectivity is essential. Dante AVIO adapters are the perfect bridge between your non-Dante audio devices and the power of audio over IP. Why do we say that? Well, the AVIOs were designed to be integrated with any Dante-connected system. AVIOs let you connect computers, mobile devices, and even legacy analog audio equipment with ease. Let's take a look at the different options and some actual use cases. AVIOs can be divided into 4 categories: analog, digital, USB, and wireless, with each group having different options. For example, using the 1 or 2 channel analog input adapter, you can take an analog signal from a mixer, wireless microphone receiver, or DSP, convert it to Dante AVIO, and send that audio to the network. In this diagram, we're taking the stereo output from an analog mixer, converting it to Dante, and sending it to loudspeaker processors, power amplifiers, and ultimately to a pair of speakers. By using analog AVIO adapters, you don't have to throw away those analog mixers that you no longer use, or replace that signal processor that you installed a long time ago. With AVIO, most common analog and digital signal types can be converted to Dante. Let's take a look at an example of how to use this AVIO install adapter in the real world. Here we have a DSP that doesn't natively have Dante. I would like to send a stereo output to this set of Dante-enabled loudspeakers. If we feed input channels 1 and 2 with some music and internally route those signals to one of its outputs, we'll see that the music is now passing through the processor. From there, we make a physical connection between the DSP and the 2-channel analog AVIO install adapter. The final steps take place in the digital domain. We'll connect the speaker where we want to hear the music, a computer to make the subscriptions using Dante Controller, and the most important part, we connect the AVIO install adapter to a PoE network switch. A PoE, or Power over Ethernet switch, is a network switch that provides both data connectivity and electrical power over a single Ethernet cable. After making the respective connections, all that remains is to open Dante Controller and make the subscriptions. That's it. We can now hear the audio coming from an analog mixer through a DSP and ultimately to a Dante-enabled loudspeaker. The other analog options are the 1 or 2 channel AVIO output adapters. This use case is the opposite of the previous example. Here the signal originates from a Dante network, and the AVIO is used to convert Dante to analog to feed a power amplifier or an active loudspeaker. In this diagram, you can see that they can be used to feed a DSP, an analog compressor, or an analog equalizer. Recording studios and home studios often have vintage analog equipment that is not directly compatible with new technologies like Dante. These facilities benefit greatly from analog output AVIOs. Let me show you. Here I have a Dante-enabled digital mixer, and I would like to send Dante audio to these two analog active loudspeakers. Using the same process as before, I connect the mixer, the computer, and the analog output AVIO to a PoE switch, and I open Dante Controller. All I need to do is route the mixer's stereo output left to channel 1 and right to channel 2. Just like that, we can listen to the music coming through the speakers. In the digital domain, there is a very useful adapter for when you have AES EBU signals that you want to convert to and from Dante. The 2-channel bidirectional AVIO AES3 adapter can be used when you have signals from mixers, DSPs, power amplifiers, microphone preamps, or recorders, as shown in this diagram. In this use case, we want to send signals from a digital mixer's AES3 output to a Dante-enabled DSP so we can feed a Dante amplifier. Once everything is connected to the PoE switch, we can open Dante Controller and wait a bit until the devices are discovered. After which, we can route the output from the AES EBU AVIO channel 1 and 2, connected to the AES3 mixer, to the Dante DSP channels 1 and 2. After the signal has been processed by the DSP, we would like to send it to the Dante amplifier. So let's send channel 1 and 2 from the Dante DSP to the Dante amplifier channels 1 and 2. At this point, if we send the signal to this loudspeaker, we can hear that the signal has been processed perfectly. There are also two USB AVIO models, a USB Type-A and a USB Type-C variant. Both models do the same thing. The only difference is the type of USB connector. This type of adapter can be connected directly to a computer, or in the case of USB-C, to a smartphone or tablet, sending and receiving signals to and from the Dante network, like in this example. This is very useful for bring your own device scenarios, such as in meeting rooms or auditoriums where there are frequently different presenters. A USB AVIO can be quickly swapped between different presenter laptops because this type of adapter doesn't need drivers or software on the host computer. Just connect it and you are ready to go. Let's see an example. Here we've got a computer running a presentation with some music. This will be sent to a mixer, and that mixer will send its output signal to a Dante-enabled loudspeaker. As expected, this computer doesn't have any Dante software to send audio to the Dante network. By using a USB-C or USB-A AVIO adapter, the presenter can send their computer's audio to the Dante network without installing drivers or software. Okay, let's connect everything to the switch. It's worth noting that in this case, if you use a USB AVIO, you no longer need a PoE switch, because your computer can power it via the USB port. If we open Dante Controller on another computer and send the USB AVIO adapter to mixer channels 1 and 2, we can see that the signal is being received and we can send it on to the speaker. If this setup is going to be consistent for a conference room or auditorium, we don't need to create these subscriptions each time. The next presenter simply plugs the USB AVIO into their computer and they will be able to send audio to the mixer immediately. Finally, in the wireless category, we have the AVIO Bluetooth adapter that can transmit audio from your smartphone, tablet, or computer to and from a Dante network. With this adapter, you can connect a smartphone to a conferencing system without any physical cabling, or you can simply send audio for background music at a live event. Let's use the example of sending music from my phone to a Dante-enabled mixer for pre-show background music. I'll connect everything to the PoE switch. And I'll press and hold the button on the Bluetooth AVIO so that my phone can discover it. I'll wait for a few seconds until it appears in the list. I can now select it, and my phone is connected to the adapter. I'll send some music, make the subscriptions in Dante Controller, and we're able to hear the music coming through the loudspeakers. As you can see, there are many different use cases and applications for Dante AVIO adapters. They're a great choice if you're looking to integrate traditional analog or AES-3 audio equipment into an AV over IP infrastructure. Dante AVIO adapters help bridge the gap between older equipment and modern networked audio workflows. Let's change gears and look at Dante software for personal computers. These days, computers are part of our everyday lives, and AV is no exception. We need them when we're using video conferencing software like Zoom or Teams. We need them when recording or editing with Logic, Pro Tools, or any other digital audio workstation. Even live production software like Ableton or QLab can benefit from a simpler connection to the rest of the production. In these scenarios, we don't want to be limited to USB endpoints. Naturally, we want to connect these computers directly to the Dante network using their existing network interfaces. If your computer has a wired 1 gigabit network port, the simplest approach is to use a virtual sound card. A virtual sound card is a piece of software that carries Dante audio in and out of a software application on your computer. In this chapter, we'll learn about the flexibility offered by Dante Virtual Sound Card. We'll also learn about the universal connectivity provided by Dante Via. These tools have redefined networked audio transport for computer software applications. Let's start with Dante Virtual Sound Card, also commonly referred to as DVS. Dante Virtual Sound Card is a software application that turns your PC or Mac into a Dante-enabled device, allowing audio traffic to be transmitted and received using your computer's built-in Ethernet port. Dante Virtual Sound Card comes in two versions, DVS and DVS Pro. The primary difference between them is the number of channels that can be achieved and the sample rates that can be used. The channel count of the standard version of DVS is adjustable from 2x2 up to 64x64 at 48 kHz, with latency the options between 4 and 10 milliseconds. DVS does use your computer's resources, so the more channels you configure, the more resources it will consume from your computer. The same is true with latency. If your computer is busy running lots of different applications, you may need to increase DVS's latency setting to achieve optimal performance. DVS can be used for a wide variety of tasks, but is most commonly used for multi-track recording, virtual sound check, or for playing out backing tracks. In addition to the standard version of DVS, we also offer DVS Pro, which is capable of higher channel counts up to 128 by 128 at 96 kHz, with latency settings as high as 40 milliseconds. Unlike the standard version of DVS, DVS Pro is also capable of being a clock leader and using unicast clocking. If you are looking for a Dante interface that can provide a higher sample rate and higher channel counts, this version is for you. As with the standard DVS version, DVS Pro uses your computer's resources, so it's highly recommended that you only configure it for the number of channels that you truly need. A higher channel count requires more system resources. There is no need to waste them by turning on unused channels. If your computer doesn't have enough resources to support the number of channels you configure, there's a greater chance of having audio glitches. If you are running a macOS computer, we recommend you read our tips and tricks for using DVS on macOS, which you can find in the link shown below or in the support section of our website. Here at Audinate, we often get asked what computer specifications are required for a machine running DVS. Generally speaking, DVS requires a minimum of a dual-core CPU with a minimum of 4 GB of RAM and a 1 gigabit network interface for any channel configurations above 32 by 32 at 48 kHz. In addition, DVS does require a license, so we recommend that you visit our website to see which license option is best for you. Once you have a valid license, you will enter it into the application, and you will need internet access to validate the license. Let's see a short demonstration of how to use it. We'll start by opening the Windows version of Dante Virtual Soundcard. Once opened, we'll see the Settings tab. In the first option, we'll choose the audio interface, either AVIO or WDM. In WDM mode, Dante Virtual Soundcard supports audio applications that use WDM audio, such as iTunes and Windows Media Player. In AVIO mode, Dante Virtual Soundcard supports audio applications that use AVIO audio, such as Steinberg Cubase and Nuendo, Pro Tools, Ableton Live, and many others. It's worth mentioning that in AVIO mode, the Options button becomes available. This button is only available in Dante Virtual Soundcard for Windows. The macOS version of Dante Virtual Soundcard uses Core Audio and has no user configurable settings. Under Options, you will see the buffer size and samples. The only thing to consider here is that computers with poor performance will need to use a higher buffer setting. If you don't really know the performance of your computer, then leaving it set between 512 and 1024 is a good option. We'll leave it set to 512 for now. Next comes encoding, which we already talked about in the Digital Audio Basics chapter. The most important thing here is that if the AVIO bit depth does not match the Dante Virtual Soundcard bit depth, all audio is truncated or padded to the value supported by the application. In this case, let's leave it set to its default of 24 bits per sample. Finally, we see the AVIO latency. This latency is different from the one that appears in Dante Controller. The AVIO latency is inserted before transmitting audio from the AVIO buffer to the Dante network. This compensates for variability in the computer's performance. We'll leave it at the default setting of 10 milliseconds. Press OK, and that's it. We're back to the main settings screens. Next, we have to decide the number of channels to use, which can range from 2x2 to 64x64 for the standard DVS, and up to 128 by 128 for DVS Pro. For demonstration purposes, we'll leave it at 16x16. Remember that the number of channels available will depend on the sample rate we've chosen in Dante Controller. For example, for the standard version of DVS, 64 channels will be available at 48 kHz, while only 32 channels will be available at 96 kHz. For the DVS Pro version, 128 channels will be available at 48 kHz and 96 kHz. For the DVS Pro version, 128 channels will be available at 48 kHz and 96 kHz, but only 16 channels at 192 kHz. Next comes the Dante latency section. In this drop-down menu, you can configure the device's latency at either 4, 6, or 10 milliseconds for standard DVS, and up to 40 milliseconds with the DVS Pro version. Any Dante device receiving audio from this instance of Dante Virtual Soundcard will use this value. The latency primarily compensates for the instability of the computer's performance, as well as delay variations found on the network. As a rule of thumb, 4 milliseconds can be used when Dante Virtual Soundcard is running on a high-performance computer. Computers with poor performance may need to use a latency setting of 6 or even 10 milliseconds. I'll leave mine set to 10 milliseconds since I'm using my computer for screen recording as well. In other words, the fact that Dante Virtual Soundcard requires a higher latency isn't really a networking consideration. Instead, it's because a virtual soundcard is a software application running in a multitask environment. The virtual soundcard is running on your CPU along with your audio and video applications, and we have to wait our turn as the CPU runs around to all the various processes. Next comes the network interface section. Here you are able to select the computer's network interface that Dante Virtual Soundcard will use to transmit and receive Dante audio. The available options will be wired Ethernet interfaces that are currently enabled on the machine. You'll notice that when we choose a network interface, it stops displaying the IP and network status. So the section below called Network Status is useful to tell us if we are at the correct speed and in the correct subnet. Finally, we just need to press Start so that the virtual soundcard starts running and appears in Dante Controller. Once it's displayed in Dante Controller, we can send signals from this stage box to the computer so we can record the incoming signals. We make the subscriptions and that's it. We can start recording to our favorite DAW. Alternatively, we can send audio out of our computer if we want to play back for a virtual sound check. In fact, we can play back the same audio that we just recorded. Or we can open a new session in our DAW and make the subscriptions from the computer to this Yamaha DM3 mixer. We simply press play in the DAW and we can immediately see the signals arriving at the mixer. The last thing worth noting is that if you have a transferable DVS license, you can deactivate it by simply pressing the Deactivate button on the License tab. After that, you can move it to another computer. Just remember that this process will require internet access. While we're on the subject of licensing, it is also worth noting that transferable licenses periodically connect to Audinate's license server to confirm the validity of the license. In the absence of an active internet connection, it will remain operational for a maximum of 30 days, after which it will automatically deactivate. To ensure continuous operation with a transferable license, you must run Dante Virtual Soundcard with an active internet connection at least once every 30 days. You can check the Dante Virtual Soundcard Licenses tab to see when the next update is required, and you can also update the license manually by clicking the Update button. This will give you 30 days before the next update is required. Okay, let's move on to the next Dante software application, which is Dante Via. Dante Via allows users to connect and share audio from applications and devices on their computers to a Dante network. This transforms a computer into a versatile audio endpoint, enabling it to send and receive audio streams to other Dante-enabled devices. It essentially turns any application on your computer to a Dante audio device, exposing it on the network. Production teams have played audio from their DAWs or video workstation directly into a Zoom conference, for example. If you need to bring multiple audio sources into the same application, Dante Via even offers a mixer with the ability to independently adjust the levels of each source. Dante Via makes the connection between software applications very easy with built-in sample rate conversion. So you can share your 96 kHz project in a 48 kHz video conference. The number of channels in Dante Via will also expand as you add routes. It supports a maximum of 32 by 32 connections and up to 16 by 16 channels to any given application. Sample rate conversion, routing between devices, and mixing takes a bit of time in the background, so Dante Via will introduce 10 milliseconds of latency. Let's see a short demonstration of how Dante Via works. We'll start by opening the Windows version of Dante Via. Once opened, we'll see all of my sources and destinations show up. Sources are in the left column, and destinations are on the right column. As we said before, Dante Via can work with multiple applications. For example, if I click Enable Dante for Zoom, it now shows up on Dante Controller. Keep in mind that if we want to expose both the transmit and receive for an application, we need to enable both sides. You can see Dante Via has kept the applications labeled automatically. If we have a Dante audio interface, we can send the connected microphone directly to the Zoom application. In Dante Controller, I'll patch my microphone from this Focusrite X2P to Zoom. Now if I open Zoom, we can confirm this subscription and see the meter moving as I speak. If you don't have a Dante mic input, and maybe you have a USB interface, you can also use that in Dante Via. Here I can see my Focusrite audio interface. If that's my mic input, I can simply drag that to Zoom. Of course, since I have a Dante mic input, I don't need to do that. We can delete it by clicking on the X. The most important thing to highlight here is that with Dante Via, you don't have to throw away older audio interfaces. This allows for a more gradual transition towards a native Dante infrastructure. Okay, so we have a good microphone for our Zoom input, but we also need to get the output of my applications into Zoom as well. To do that, just as we did for the USB interface, we drag the DAW onto the Zoom application. As I mentioned earlier, if any of these inputs were at a different sample rate, Dante Via will convert them to 48 kHz automatically. Remember that all audio in Dante Via is converted to 48 kHz. Now that we have multiple inputs coming into Zoom, Dante Via will mix these together for us. Dante Via even offers simple level controls, so you can adjust the levels to make them just right. Now that everything is in Zoom, we just need to set up our monitoring. We'll want to hear the Zoom output plus the output of the DAW. If you're using a USB interface, we can mix the signals right in Dante Via. We just drag Zoom and our DAW to the USB output device. Again, we have a mixer and we can adjust the levels there. In this case, I have an external mixer that I want to feed everything to. So in Dante Controller, I'll patch them into my mixer, and now I have physical fader controls. We can now have our Zoom call with direct patching for our applications and a good set of mics and speakers. You may be wondering why you would choose Dante Virtual Soundcard versus Dante Via. Realistically, each program has advantages in certain circumstances. DVS and DVS Pro offer simplicity with more channels, higher sample rates, and lower latency. Dante Via offers routing between applications and sample rate conversion. You can install both DVS and Dante Via on your computer, but you can only use one of them at a time. If you need to switch applications, you can disable Dante Virtual Soundcard and enable Dante Via. Okay, this was a lot of information. Let's summarize this chapter. Audinate's OEM manufacturer products provide digital audio and video networking solutions, including chipsets like the Pro S1 and Brooklyn 3, and software solutions like IP Core and Dante Embedded Platform. Audinate's AVIO adapters enable seamless integration of non-Dante devices into audio over IP systems, supporting analog, digital, USB, and wireless connectivity. Computers play a vital role in audio and video production, and tools like Dante Virtual Soundcard and Dante Via integrate seamlessly into those workflows. DVS and DVS Pro enable Dante audio traffic on PCs and Macs, offering channel counts up to 128 by 128 at 96 kHz, and latency adjustments up to 40 milliseconds. These tools are ideal for tasks like virtual sound checks and recording, but they do require system resources proportional to their configuration. Dante Via transforms computers into versatile audio endpoints, It enables routing between applications, sample rate conversion, and integration with existing hardware for tasks such as mixing multiple sources or connecting DAWs to applications like Zoom.